This next video is on simplifying a trigonometric expression where you need to add and subtract. And again, this is the same skill as you need to add and subtract rational expressions. And it's sometimes easier to start there. So if you want to practice with just x's and y's first, go to page 880 and do the just-in-time 20. If you're feeling confident with rational expressions, we can move on to including trig. So the first thing I want to notice is that this fraction is getting squared. So I'm going to rewrite it as sine squared x over cos squared x minus 1 over cos squared x. Then you should realize that these two fractions already have a common denominator, so I don't have to create one. It's cos squared x. So I can write it as a common denominator, cos squared x, and I can perform the operation in the numerators. So this is sine squared x minus 1. Now the question is this fully simplified? Well, I'm hoping alarm bells are going off and you're seeing a 1 with a squared trig expression, so you're thinking Pythagorean identities. The Pythagorean identity would be sine squared x plus cos squared x equals 1. Now this one's a little bit different, and this I really want you to pay attention to because there's always a trig identity that involves this, and people mess it up every single time, and they're so close yet so far. So normally when we've looked at the Pythagorean identity, we've gone 1 minus sine squared x, and we've just subtracted sine squared x from each side. This one is sine squared x minus 1. To get that, I'm going to subtract the 1 from each side so that it's on the right. I'd have sine squared x minus 1. Now I don't want the cos squared x, so I'm going to subtract the cos squared x from each side. That's going to leave me with sine squared x minus 1. Then cos squared x minus cos squared x is gone. 1 minus 1 is gone, equals negative cos squared x. So I'm replacing sine squared x minus 1 with negative cos squared x over cos squared x. So this should simplify to negative 1. And lots of people get positive 1 and then they're confused and they look at the answer key, so they just make it work and put a negative somewhere. But this is where the negative comes from, is it's a different rearrangement of the Pythagorean identity. Okay, next one. So this is one that I've gone down the rabbit hole before, and I've said, oh, look, I'm going to add fractions. This is cos x over 1 plus sine x, and this is tan x over 1. And then I've created this common denominator of 1 plus sine x, and then I get this crazy expression that has sines, cosines, tans, and it just gets enormous and confusing. So what you have to recognize in this expression is because this is in cos and sine, by adding in a tan, you're adding in this third expression, which makes things more complicated. So what you're going to do is use your basic identity first to change the tan x. Sorry, I can't talk and write at the same time tonight. I'm going to change the tan x into sine x over cos x. Because now everything is in sines and cosines, and it'll be much simpler. Try it the other way, see the rabbit hole you go down, and it is possible to get out, but it's way harder because you'll end up with complex fractions and things will be messy. So here's my biggest advice. Make everything in sines and cosines if there's a sine and cosine there. Now we need to create a common denominator. So remember, to create a common denominator, the only thing you can do is multiply by something. So this denominator is 1 plus sine x, this denominator is cos x. So my lowest common denominator will just be cos x times 1 plus sine x. So to create that common denominator, the first fraction I'm going to multiply by 1 plus sine x over 1 plus sine x. Remember, I'm allowed to do it because as long as you multiply by 1, you haven't changed the value of your fraction. And then this one I'm going to multiply by cos x over cos x, and I'm going to put the bracket in there. Okay, so what does my next line look like? Well, I've created this common denominator of cos x times 1 plus sine x. And then my numerator is going to be cos x times cos x. So I'm just going to write that as cos squared x plus sine x times 1 plus sine x. Now I am going to be distributing the sine x through, but I like to write this step first because then if there's a minus sign here, I remember to distribute minus sine x. But this one's just a plus sine x, so I'm going to keep going. So again, my denominator is cos x times 1 plus sine x. My numerator will be cos squared x plus sine x times 1 is sine x. Sine x times sine x is sine squared x. Okay, now what? So again, I'm seeing these squared trig values. I've got sine squared x and I've got a cos squared x. Well, if I rearranged this expression to be sine squared x plus cos squared x plus sine x, you get hand cramps in this chapter, all over cos x times 1 plus sine x, it might be easier to see what to do next. So using the commutative property of addition, I was allowed to take the sine x and just write it out in front. Okay, it doesn't matter what order I do addition in. But hopefully now you can see this trig identity, this Pythagorean identity. And sine squared x plus cos squared x can be replaced with a 1. So now I get 1 plus sine x over cos x times 1 plus sine x. And it's at this point you should start getting the warm fuzzy tingles going, I think I did it right, because look, I can simplify. 1 plus sine x divided by 1 plus sine x is gone, and I would be left with 1 over cos x. All right, so there wasn't a lot of practice in the textbook on this. There's only 2 quick check questions, but this is a really important skill that we'll come back to in 7.3. So do try those 2 questions. And again, if you're doing an even question, there is a solution on the Moodle site. All right, good luck.